Bismillahirrahmanirrahim. This is Sayyid Wasim Ali, and now we will be discussing the morphological classification of anemia. Okay, so anemia is classified into microcytic anemia, normocytic anemia, and macroacidic anemia on the basis of mean corpuscular volume. What is the mean corpuscular volume? Mean corpuscular volume is the average volume of RBCs in specimen. The normal value of mean corpuscular volume is 80 to 100 micrometer cube or femtoliter. When this mean corpuscular volume value is less than 80 micrometer cube or femtoliter, then we call it microacetic anemia. Or when the mean corpuscular volume value is greater than 100 micrometer cube or femtoliter, then we call it macroacidic anemia. Now, why microacidic anemia occurs? So it is because of decreased hemoglobin production. The hemoglobin, when there is decreased hemoglobin production, so in order to maintain the hemoglobin concentration in the red blood cells, these red blood cells will undergo one extra division, and the average volume of the RBC in the specimen will become less than the normal, and we will get the value of mean corpuscular volume less than 80 micrometer cube or femtoliter, and a condition called the microacetic anemia. In contrast to it, here we have folate or vitamin B12 deficiency in macroacetic anemia, where there will be the impaired cell division, and the RBC will remain bigger than the normal. The different now in normocytic anemia, we have the main corpuscular volume whose range falls in normal value, but here the causes are other than the hemoglobin production or deficiency of folate or vitamin B12. The microacetic anemia are of four types, that is the iron deficiency anemia, anemia of chronic diseases, sideroblastic anemia, thalassemia. And all these are relevant to the decreased hemoglobin production. We all know that hemoglobin is formed from the heme and globin chains. Again, the heme is formed from the protoporphyrin ring and iron. So when there is iron deficiency, it will cause the decreased hemoglobin production and will cause microacetic anemia. Similarly, anemia of chronic disease, we have increased store of irons, which is not available for the heme production and eventually for the hemoglobin production. And sideroblastic anemia, we have a defective the protoporphyrin, while in thalassemia, we have defective globin chains. And macroacidic anemia, we have the megaloblastic anemia, alcoholism, liver disease, and drugs. All these diseases we will discuss in the upcoming lectures in a big detail. In normocytic anemia, we are having the hereditary spherocytosis, sickle cell anemia, HBC, hemoglobin C, and hemoglobin S in sickle cell anemia, PNH, G6PD deficiency, immune-mediated hemolytic anemia, microangiopathic hemolytic anemia, and malaria. You can memorize all these diseases by the mnemonic HSHB, PGIM. So H for hereditary spherocytosis, S for sickle cell anemia, HP for hemoglobin C, P for paroxysmal nocturnal hemolytic anemia, G for G6PD deficiency, I for immune-mediated hemolytic anemia, M for microangiopathic hemolytic anemia, and M for malaria. All these diseases will be discussed in very detail in the upcoming lectures. And that's all for the morphological classification of anemia.